This is the first part of section 9.1. In this chapter, we're going to be learning a whole bunch of different formulas and stuff. You're going to end up with another formula sheet, but for this first section, we're just going to make use of the formulas that we already have from your first formula sheet. So I will refer to that on occasions. So if you want to have that handy, I am going to refer to this on occasions. But once we get into section 9.2, then we're going to move on to another formula sheet. So in this section, we're going to be doing something called verifying an identity. In order to do that, you're going to show that the two sides of this expression are in fact equal. Now, the thing about this is that you're used to solving equations where you can manipulate both sides. All right? You're used to equations where you can like add 2 to both sides and square both sides and things like that. We can't do that with an identity because we don't know. Sorry, big yawn. We don't know that the two sides are equal. So we can't treat it like an equation. So what we need to do is start on one side, simplify it, and try to get it to look like the other side. So don't treat this like an equation. You cannot move terms across the equal sign. You can't do things to both sides of the equation. Okay? Your job is to verify that the two sides are actually equal. Now, how do we do that? Well, we make use of the formulas that we have so far. And we have things like the Pythagorean identity, the even-odd properties, the reciprocal and quotient identities. So those are the ones we're going to make use of. So let's start off small. I have all these written up really nicely. I just don't want to show you the answers initially here. So if we're going to look at cosine x times cosecant x equals cotangent x. My strategy for these is to always start on the more complicated side and simplify it to look like the other side. Remember, this is not an equation. You cannot do something to both sides. So I'm initially drawn to this left-hand side. So I always make a note of what side I start on. So in this case, I started on the left-hand side. So that's what that left-hand side is, that LHS. That tells me what side I start on so that when I'm done, I know I should end with the stuff on the right-hand side. And I do that because as these get more complicated and complex, it's possible that you can start on one side and accidentally end up on that same side, therefore not actually verifying the identity. You just kind of go in circles. Now we know that cosecant is a reciprocal property. So the cosecant is 1 over the sine. Well, we know how to multiply fractions, right? We multiply straight across the top and we multiply straight across the bottom. This is a quotient identity. Cosine over sine is the same as cotangent. Booyah! There we go. That's the right-hand side. We're done. We say that this verified this identity. We verified that this product was in fact equal to cotangent. Now you don't have to worry. I'm not going to ask you to verify anything that's not true. So I'm not going to ask you to verify an identity that's not going to work out. The whole point of saying, verify means that, hey, it is true, show me it's true. But you cannot assume it's true. So at this point of saying cosine, goes 1 over sine, you can't multiply. Oh, another yawn. Sorry. I could hit re-record and do this again, but whatever. See the real side of how this plays out. You can't multiply both sides by sine and cancel anything out. So again, you start with one side, you manipulate it using the formulas that we know, you end up on the other side. Cool? Cool. All right, so let's just keep doing some. We're going to do just a whole bunch of examples to kind of give you some strategies to follow. Okay, mostly what you're going to use is going to be the Pythagorean identities and the like quotient and reciprocal identities. Those are going to be mostly what you use. But we're also going to have to use some operations. We're going to have to like add fractions, you know, and add or I'm sorry, rational expressions, and you know, multiply, divide, things like that. Okay, so looking at this next one, we have cosecant x minus cosecant x cosine squared x equals sine x. Ooh, that's all kinds of wonkadoodle, isn't it? All right, you guys know I'm going to start with the more complex side, and I'm going to simplify it until I get to the other side. It's not always the case that the left side is the more complicated one, but for these first two, yeah, seems the left-hand side is the more complicated. Wouldn't you say that that's a lot more complicated than that? Yeah. So we're going to start there. We got cosecant x minus cosecant x cosine squared x. We need to do some algebraic manipulations to make this big fat daddy expression here equal just sine x. Well, notice that there's a cosecant that's common to these two terms. So I'm going to factor out a cosecant x from both of these. Now remember, factoring is like the opposite of distributing, right? So dividing out that cosecant x here, I get 1. Dividing it out from there, I get cosine squared. Now does 1 minus cosine squared look familiar? It might. This is one of the variations on the Pythagorean identity. You know, the actual Pythagorean identity that we know is sine squared plus cosine squared equals 1. But if I do a little algebraic manipulation on this, you know, and I subtract cosine squared from both sides, I get that version. So this is the same thing as sine squared. Now you might be thinking, you said I couldn't do something to both sides of the equation. I did when you're verifying an identity. This is not something to be verified. We know this to be true. So this is taking a known formula and manipulating that equation. So I replace that 1 minus cosine with sine squared. Now remember, cosecant is 1 over sine times sine squared. Well, that sine cancels out one of those sines, and I'm left with sine x. Look back up here. That's my right-hand side. There it is. Now, as we go through these, you're going to see that you can use this side to kind of help guide you. You know, you kind of keep looking up here like, okay, am I headed toward this? You know, so you got down here and you're like, all right, I got this combined into, you know, one term, got rid of the subtraction. So maybe when you get to this point, if you're kind of stuck and you're like, oh, I don't really know where to go from here, I don't know what to do, then maybe you can say, oh, well, I'm looking over here at what I'm supposed to end up with, and let that kind of guide you. All right, so when I post the notes, you'll notice that I have this written up all nice and color-coded and stuff for you. I'm just trying to go through them one at a time with you without showing you the answers as we go. Alright, so number 3, we're going to verify the identity. This one is cosine squared x minus sine squared x equals 2 cosine squared x minus 1. Alright, so we got to pick, you know, like I said, I usually pick the more complicated side to start with and simplify it to make it look like the other side. This one's kind of tough. I mean, which one's more complicated? You know, you could make an argument that either one of them's more complicated, but For me, I think that the cosine squared minus sine squared is a little more complicated just because it involves, the cosine and the sine. So I would start on the left-hand side for this one. Now remember how in the last example we had that Pythagorean identity where we said that sine squared was 1 minus cosine squared. Remember that from such hits as example 2? Boop. All right, I'm going to make use of that again. I'm going to replace that sine squared. So I'm starting on the left-hand side. I'm going to replace sine squared with 1 minus cosine squared. So minus sine squared, which is that 1 minus cosine squared. Now why did I choose to do that? Because the side I'm working toward does not have a sine squared anywhere near it. So I needed something that I could replace this with that would get rid of the sine function. And the squared, whenever you see a squared, you need to think of the Pythagorean identity. All right? Those squares, just more often than not, you're going to end up using some version of the Pythagorean identity when you see those squares. So just keep that in mind. Now, because this subtraction is for this entire quantity, I do have to distribute that negative. So I'm going to get cosine squared x minus 1, and then that's going to be that negative times that negative. So that's plus cosine squared x. Now look, here's where I want to end up, over here. Where's that 2 going to come in? Look, minus 1. Oh, I see you, minus 1. Look, I've got cosine squared x plus cosine squared x. So that's 2 cosine squared x minus 1. There's the right-hand side. I'm done. So the goal is to start with one side, manipulate it using the formulas that you know, and make it look like the other side. So I always start with the more complicated side. I make a note of what side that's going to be. And then I use the formulas that we have established from that first formula sheet. The quotient, the reciprocal, the Pythagorean identities. You may have to do other things in there, such as factoring, distributing, combining like terms, adding, subtracting, things like that. Okay. Scooch down here. Example 4. Verify the identity. So we have cosine theta times secant theta divided by cotangent theta equals tangent theta. Now remember, this is not an equation, so don't try to multiply both sides by cotangent to make this look nicer. No, no, no. Pick a side, start with it, manipulate it to look like the other side. Now there is actually another way you can do these. It's called meeting in the middle. It's a little more complicated, but it can be done. But if you want to manipulate, if you have two sides that are kind of complicated, you can manipulate one side, manipulate the other, and if you can get those two things equal, then that also verifies the identity. But for most of these that we're going to do, we'll be able to start with one side and work our way to the other. All right, so I think we can agree that the left-hand side is, again, the more complicated side. That's pretty typical that it's the left-hand side. Not always, but frequent enough. So that's the side I'm going to start with. I don't see any squares anywhere, so I'm probably not going to use a Pythagorean identity. But I am going to change all this into sines and cosines. Just, maybe see what happens. So let's change that secant. That is 1 over cosine. Oh, that's really nice, isn't it? You know what? I don't think I'm going to change that cotangent. I was going to, write it as cosine over sine, but I don't think I'm going to do that now. Because as soon as I took that secant and made it 1 over cosine, check out what happens. Those cancel. Do you see what I get? I get a 1 on the top here, and I have cotangent on the bottom. That's a reciprocal identity. 1 over cotangent is just tangent. I'm done. Now some of these to start with are going to be pretty quick. So don't be surprised if you get the answers pretty quick like this. Some of them will be. Some of them are going to be more involved as we go through it, and they're going to get longer and more complicated and stuff. So if you get some that are kind of longer, don't assume that you're doing it wrong. Some of these are going to be really quick and painless, and some of these are going to be long and painful. So that's just how it's going to have to be. Okay, so let's do example 5. So this is cosine x times cotangent x equals 1 minus sine squared x all over sine x. Okay, so which side is the more complicated side? It's a little bit fuzzy, isn't it? Let me see if I can sharpen that up a little bit. Well, I don't know about you, but I think the right-hand side is more complicated. I think this side's more complicated because of the fraction than this side. So I'm going to start over here. If you choose to start with a different side, that's okay. You could still verify the identity. It just ends up being a little bit more difficult sometimes to have to make things more complex than it is to take something that's complex and make it a little nicer. Alright, so let's start on the right hand side. So I get that 1 minus, oops, not cosine, 1 minus sine squared x all over sine x. Alright, whenever I see a 1 and a squared, I immediately go to those Pythagorean identities. Right? So we know that sine squared plus cosine squared equals 1. So if I subtract sine x from both sides of this equation, I get cosine squared x is 1 minus sine squared. So I can replace that 1 minus sine squared with cosine squared. So that comes from using a Pythagorean identity. Now this is kind of the messier version of it. When you look in the more, the nicer notes here, I got it all color-coded for you. So it's a lot prettier in these notes. Alright, so you look at this. Now, this right here, don't forget, right-hand side, I'm now trying to make it look like this. Well, okay, cosine. I see I have a cosine. Actually, I got two of them. Right? I got cosine times cosine. How am I going to get a cotangent out of this? Well, look closely here. This is cosine times cosine, right? Cosine squared over sine x. Remember how we multiplied fractions by multiplying straight across the top and straight across the bottom? Well, I can separate those fractions in the exact same way. So if I do that, you see what's about to happen? If I pull these fractions apart, I get cosine x over 1 times cosine x over sine x. Well, cosine over sine, that's a quotient property. That's cotangent, which is the left-hand side. There. So I always note what side I start on so that I know what side I want to finish with. Otherwise, as these get harder, you may accidentally start on one side and just end up doing a whole bunch of stuff and then end up right back where you started, in which case you didn't, verify the identity. So my goal is just to make sure that you know where you started so that you know where you're going to end. Okay, let's do a couple more. So this is going to be example 6. Now this whole chapter isn't on verifying identities. We are going to talk about a whole bunch of other kind of formulas and other pretty cool stuff with trig. But the identities are always going to kind of be looming in the background. Right? We're kind of always going to have them there. Like, we'll do the sum and difference formula, and at the end it'll be like, hey, here's some identities. Like double angle, boop, here's some identities. So they're going to kind of keep popping up here and there. So cotangent x plus sine x over 1 plus cosine x equals cosecant x. These identities were always my favorite part of trig. I don't know, they're like little puzzles. They're pretty cool to me, but I don't know, I'm kind of weird. So I think we can agree that the left-hand side is the more complicated side of these two. So I'm going to start on this left-hand side. I've got cotangent x plus sine x over 1 plus cosine x. All right, well, first thing you should notice is that there is addition, and there's no addition here. So obviously we have to combine this somehow. So we are going to have to get a common denominator for these two. It's kind of up to you how you want to do this. I did this a couple of different ways to start with, and I kind of settled on one particular way that I liked more than the other one. I chose to take this cotangent and write it as cosine over sine. Now I did that because eventually I have to do that anyway. It does, however, make finding a common denominator a little messier. This is a pretty common technique in most textbooks, is to write everything in terms of sines and cosines. You certainly could have worked from this point and got a common denominator of 1 plus cosine x. It would have been a little messier later because you would have ended up with like a complex fraction. So I just rewrote cotangent as cosine over sine. Now I have to get a common denominator. In order to do that, first of all, the common denominator is going to be the product of the denominators. So I'm going to have to multiply this fraction by this denominator over itself, and then this fraction by this denominator over itself. All right. So here's what's going to have to happen. To get that common denominator, I'm going to have to multiply this fraction by the same thing top and bottom. Now what this is, this red stuff, this is just 1. So this is not the same as saying, oh, well, you multiplied both sides of the equation by the same thing. No, no, no. This isn't both sides of the equation. This is multiplying a fraction by 1 in the form of something over itself. Remember, multiplying a fraction by 1 doesn't change a fraction. It just makes it look different. Just throws lipstick and a dress on it. Same thing over here. I just multiplied by 1. I'm just very specifically choosing the one that I'm going to use. Now in doing so, and I'm showing you this because it's color-coded, in doing so I get the common denominator of sine x times the quantity 1 plus cosine x. So multiplying this out, and then multiplying this out. I can add these two fractions by adding my numerators over my common denominator. I am going to have to distribute that cosine, and of course those two are going to multiply out to be sine squared. So I end up with cosine x times 1 plus cosine squared x plus sine squared x. Now remember what I said, whenever you see some squares, you need to think, do I need the Pythagorean identity of some kind? In this case, look, it's cosine squared plus sine squared. Boom, that's 1. That's a Pythagorean identity. So I can replace all of that mess right there with just 1. Not 1 plus, not 1 minus anything, just that plus that equals 1. So I'm trying to, use this one just because it's a little more color-coded. So I get cosine x plus that 1 from the Pythagorean identity over this stuff. Now here's what ends up happening. I get that cosine x plus 1 over that common denominator. This is 1 plus cosine x, that's 1 plus cosine x. So those two cancel. The cosines don't cancel, the 1s don't cancel, the entire term, the entire factor cancels. The individual terms do not, the entire factor does. So check it, I'm left with just 1 over sine. Remember where I wanted to end up? Cosecant. Done. So there we go. So this is an example of one that gets a lot more, intense. There's a lot of messy stuff happening with this. So my job is to make sure that you have kind of a bag of tricks to use. That you say, okay, let me try a Pythagorean identity. Let me try a quotient identity. Let me try getting a common denominator. It's just a bunch of different techniques that you can try until you find one that's going to work nicely. Okay, last example. I know this is a long video because this is a lot of stuff to have to do. So last one for this part, and there's going to be more in the next part of the video. So we're going to verify the identity of sine x over 1 plus cosine x equals 1 minus cosine x over sine x. Now you know what I like about this one? It's not obvious which side is messier. When you're looking at that and you're like, okay, let's start with the more complicated side. Which one is that exactly? I chose to start with the right hand side. Why? I don't know, because in comparing these I was like, well, I guess subtraction is a little more complicated than addition. So yeah, I chose to start with that right hand side. So that's the one I'm going to start with this time as well. You certainly could have started with the left hand side if you wanted to here. A common trick that we can use if one side has like a minus and the other side has the same thing but with a plus, a common trick that we use is multiplying by the conjugate. Now that term might sound familiar. So this is multiplying by the conjugate of this 1 minus cosine x. I'm multiplying by the same thing top and bottom. So I'm just multiplying this fraction times 1. Doesn't change the value, just makes it look different. Now, what's the perk of doing that? Well, let me show you. So I now have two terms to multiply on the top. So we're going to have to distribute all that out. So that's going to be 1 times 1, and then 1 times cosine x, negative cosine x times 1, negative cosine x times positive cosine x. Now look at what happens when I distributed all that out. I ended up with a positive cosine x and a negative cosine x. Those went away. That happens when you multiply this binomial by its conjugate. So it's not like, oh, that's kind of nifty that happened. What a crazy coincidence. No. That totally should have happened. We planned that. That's why we picked this conjugate to multiply by. Now I'm not going to distribute this out. And you're going to see why. Because a lot of times with this kind of stuff, some of the stuff, if you distribute it out down here, you're just going to have to refactor it. But also, I'm not distributing this out because I started on the right-hand side, so let's look over here at the left-hand side. Ooh, see that 1 plus cosine x? I see you, 1 plus cosine x. So somehow that's going to go away. Okay, let's keep going. So we get 1 minus cosine squared over sine x times 1 plus cosine x. Alright, remember what I said, if you see a 1 and a squared, think of the Pythagorean identities. This one, this 1 minus cosine squared, is a version of the Pythagorean identity. I thought it was on that previous page, but I guess it was a couple pages back here. Where was it? Oh, wait, we did the 1 minus sine squared. Okay. No. Good a time as any to do this one. So if you have sine squared plus cosine squared equals 1. If I subtract cosine squared from both sides, I get sine squared x equals 1 minus cosine squared. So I'm going to replace that with just sine squared x. Now how does that help us? Well, keeping our eyes on the prize here, again, right-hand side is where we started. That tells me this is where I want to end up. So if I want to end up with sine over 1 plus cosine, well look, I've got sine x, and then I've got sine x times sine x. So this sine is going to cancel one of those and leave me with sine x on the top and that 1 plus cosine x on the bottom, which is my left-hand side. And if you look at the notes, I did color code this for you so you can see like the Pythagorean identity uses and stuff. But it is nice to know that when you get to the Pythagorean identities, you have that sine squared plus cosine squared equals 1. And then you have their algebraic variations of sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. So those are all equivalent. So just know that going in, that if you see something that has a sine and a cosine squared, or a sine squared, a cosine squared, and a 1, that you can use this version on the formula sheet, or it's two kind of algebraic manipulations of that. Okay, so that concludes the first part of this section.